Hello students, today's lesson is the introduction to organic chemistry, and I'm a chemistry teacher. My name is Zhexenbek Toktarbay. And objective of today's lesson is to understand specificity of organic compounds in terms of their structure. Okay, this is very first lesson in organic chemistry, so let's learn what is the organic chemistry. The organic chemistry is the study of carbon-containing compounds. Why we need to learn organic chemistry? Because every living organism is made of organic molecules, and we need to improve our living standards. For instance, we want to make medicines, we want to make plastics and pesticides and etc. And we need to learn organic chemistry. And how can we make medicines and plastics and pesticides and many other things? By examining the structure and the reactivity of these organic molecules. And this is common examples of organic molecules in our daily life. For instance, our foods, our fruit, and our cosmetics and DNA, perfume, soap, paints, all these things are good examples of organic compounds. And here listed a number of inorganic molecules as well. And nowadays there are 37 million of known chemical compounds in the world. And 99% of these known chemical compounds are the organic molecules. And why this carbon molecule is so special, containing 99% of the whole molecules in the world? Now let's answer this question later. Now let's begin the structure of this carbon. And as you know, the carbon is the sixth element in the periodic table with the atomic mass 12. And this is the electron configuration of the carbon. And as you know, the electron configuration of the carbon is 1s2, 2s2, and 2p3. And here this is outer shell, and the carbon has 4 electrons in its outer shell. And now let's recall what we learned before. We learned the structure of water, structure of ammonia, and structure of methane. And now let's come to this water molecule. And the oxygen itself has 6 electrons in its outer shell, and it needs 2 electrons to fulfill 8 electrons, which means 8 electrons means to fulfill the stable state. And here the oxygen has 6 electrons in its outer shell, and it needs 2 electrons to fulfill the stable state. And here the hydrogen has only 1 electron, and for oxygen, the oxygen needs 2 hydrogens, because hydrogen has only 1 electron, and this oxygen needs 2 electrons, so it needs two hydrogens. So 2 hydrogens bonded here, and there's 2 electrons shared by this oxygen and the hydrogen, and 2 electrons shared here between this oxygen and hydrogen, and 2 electrons make one single line. We call it bond. And in case of this nitrogen has 5 electrons in its outer shell, and it needs 3 electrons to fulfill 8, or stable state. And it needs 3 electrons. Remember, okay, this hydrogen has only 1 electron, so this nitrogen needs 3 hydrogen to fulfill its stable state. Okay, this hydrogen now added three hydrogen here, and there's a shared electron here and here and here. This between this nitrogen and the hydrogen, and forming here three single line or three single bond. And in case of this carbon has 4 electrons in its outer shell, and it needs 4 electrons to fulfill the 8 electron stable state. Okay, so in this case, this carbon needs 4 hydrogen, and the carbon bonded with this 4 hydrogen here, and this is the shared 2 electrons between carbon and the hydrogen, and this is another 2 electrons shared between hydrogen and the carbon. And so here this carbon made the 4 line or 4 bond or 4 single bond. One single bond is made of 2 electrons. Okay. Now let's consider this bonding between the carbon and oxygen. And oxygen needs 2 electrons, as I mentioned before, because the oxygen has 6 electrons and it needs another 2 electrons to fulfill the 8 electron stable state. And this carbon has only 4 electrons. And if this oxygen wants to bond with this carbon, and the carbon must give 2 electrons to this oxygen, and in that case this carbon has another 2 unbonded electrons here, and this unbonded 2 electrons grabbed by this another oxygen molecules, and so these two electrons of this carbon and bonded and shared these 2 electrons of oxygen, and here these 2 electrons of this carbon, and shared or bonded by these 2 electrons of oxygen, and here this 2 paired electrons or 4 bonds, and the 4 bonds can make 2 line or double bond like this, and here another 4 electrons or 2 paired electrons, and this is here another double bonds. And you can see the single, double and triple bond like this. A single bond is formed between 2 electrons, and the 4 electrons form this double bond, and 6 electron or 3 paired electron form triple bond like this. Okay, now let's come to the bond formation of the carbon. And the carbon, as I mentioned before, the 4 electrons has its outer shell, and it can make 4 bonds. These 4 bonds between, if the carbon attached another carbon molecules, another carbon atoms, these 4 bonds could be in these 3 ways. It could be single bond between carbon and carbon. It could be double bond between carbon and carbon. It could be also triple bond. If the single bond between the carbon here, this carbon has another 3 bonds. It can add another 3 hydrogen, and in this case also it can add another 3 electron, and in this case there's 2 electron of this 2 electron of this carbon consumed here, and it has another 2 electrons, so it can form 2 another bond in this case, and 3 electrons of this carbon used here, and here the carbon has only 1 electron, and this carbon can have only 1 bond here, and this carbon also can have only 1 bond here. Okay, Now let's consider the structure of 3 carbon atoms. 3 carbon atoms, it could be like this. Okay, the 3 carbon atoms attached each other by this way, and this carbon atom, as I mentioned, it has 3 unbonded electrons, so it could add 3 hydrogens. And this carbon bonded 2 electrons, 1 electron right here and 1 electron bonded between these 2 carbons, 1 electron bonded these 2 carbons. So this carbon has another 2 electrons on here and here. So that's why this carbon can have only two hydrogen. And this carbon used only 1 electron, so it can form another 3 bond. So this carbon can have only 4 electrons. So count the bond of this carbon. So 1, 2, 3, 4. And count the bond of this carbon. 1, 2, 3, 4. And this carbon also 1, 2, 3, 4 bonds. So carbon can have only 4 bonds in organic chemistry. And let's consider this case, 3 carbon and 6 hydrogen. And you can draw only like this. There's no other way you can draw this molecule. Okay, this is there is a double bond between these 2 carbons, and this carbon used 2 electrons here, and this carbon have another 2 electrons. It can have 2 hydrogen. Okay, in case of this carbon used 2 electrons here, and it used 1 electron between these 2 carbons. So this carbon used 3 electrons, and this carbon has only 1 electron to form only 1 bond. And in case of this carbon used only 1 electron between these 2 carbons, and this 2 carbon has another 3 electrons to form another 3 bond like this. Okay, what if the C3H4, now 3 carbon, 4 hydrogen? We can draw only this way, and there is a triple bond between these 2 carbons. And so this carbon used 3 electrons here between these 2 carbons, and this carbon has another 1 electron here to bond another hydrogen. And this carbon used 3 electrons here and used 1 electron here. So this carbon has no any extra electrons to form another bond. This carbon has now 4 bonds. And this carbon used 1 electron here, and it can have 3 another bonds to form this carbon hydrogen bond. And we can write the first 1C, this H3, and 1C, H2, 1C, H3 in the like this. This is another form of the structure. This is called linear structure, and it's called condensed structure. This C, 1C, that's bonded 3H. This 1C bonded 2H. This is 1C bonded 3H, like this. This C bonded 2H, and this C bonded 3H. This C bonded 3H. Or you could write like this. This 1C bonded 2H, this carbon bonded 1 hydrogen, and this carbon bonded 3 hydrogen here. This is 3 hydrogen, and CH is this one, and CH2 is this one. Or in this case, C3H4, you can draw the linear structure like this, and the condensed structure like this. And this is the CH, and this is this CH, and the C, only C, and here's CH3. You can draw the linear structure like this, and this is called condensed structure. Okay, let's come to this molecule C4H10. How can the structure of this molecule be? You can draw only these two molecules in this case. First, the linear by attaching this 4 carbon each other, or you could draw also like this, and 3 carbon linear and 1 carbon branched. And this is called this is name of this molecule is butane, and the name of this molecule is isobutane. But the name and the properties of these molecules we will tell you later. And okay, the different structures of the carbon hydrogen. And okay, let's consider this the C4H8, this molecule. How many drawings or how many structure can this be? Okay, you could draw like this, or you could also draw like this by this linear structure, and you could also draw like this as branched. This 1 carbon, 3 carbons linear and 1 carbon is branched. And you could also draw like this ring. This is square ring, the rectangular structure of this this molecule, and this is the triangular structure, and another carbon you can add here, and so now you can draw the C4H8 only this by only this 5 ways. Okay, this is the end of our lesson, and the homework for this lesson is draw an organic molecules using more than 3 carbon atoms using single, double, or triple bond. This is the example has been done for you. This I used here 5 carbon atoms. I used here single, double bond, and triple bond here. Remember, the carbon has only 4 bonds, and here everywhere in this structure carbon has only 4 bonds, and the hydrogen can have only 1 bond. That's the end of today's lesson. Thank you for your listening.